It's our next presentation here at the Planet MicroCap Showcase Toronto in partnership with MicroCapClub. It is presenting on behalf of California Nanotechnologies. We have Eric Eierman.
Hello, everyone. Yeah, thanks for coming out. As you mentioned, my name is Eric Eierman, CEO of California Nanotechnologies, also known as Cal Nano. So quick background. So Cal Nano was founded in 2007. I actually started the company in 2014 as an intern, and then over the course of about 5 years, worked my way up to CEO, and that's where I've been ever since. So let's get going. So at Cal Nano, we are on a mission to bring the next generation of materials to market using our cutting edge technologies. So what exactly does that mean? So what we're doing is we're working with universities, national labs, startup companies to the largest Fortune 500 companies to develop and manufacture advanced materials and their next generation of products. And this kind of ranges in industries from aerospace and defense to automotive to biomedical to many things in the energy sector. And here you see a list of the kind of different applications that kind of we're working with customers on. And like I said, it ranges all across different industries from engine components to reactor materials, not up here, but like heat shielding, armor materials, special materials called thermoelectrics, and then even into the high-end automotive brake discs. And we're working with them in order to basically either enhance products that they already have or develop completely new products with better mechanical properties, thermal properties, electrical properties. Really depends on whatever the application is. So here, looking a bit at the history of the company, or just the past probably 6 or 7 years. As I mentioned, I started in 2014. By 2018, 2019, I had become CEO. We were still pretty low revenues, less than $500,000 in revenues at that time, and a pretty significant debt load. So that's when I started to kind of revamp the company and figure out kind of where we're going to go and how we can get to profitability, become debt free, and that's really where we've been over the last 2 years. We've made that transition. We've gone from at the lowest point about 3 employees up to now 20. We became debt free at the end of last year, opened up a new manufacturing facility going from about 3,000 square feet to 20,000 square feet. Bunch of new equipment that was put into that facility, which I'll get into the technology in a minute here, and started to kind of transition from being just purely an R&D kind of prototype house into now looking with this new facility to become a contract manufacturer for these customers that we have, from startups, like I said, to the large ones. And we also got our ISO certification for kind of a quality certification for manufacturing. So here, this is a little bit looking into the future a bit for our kind of strategy and our objectives moving into next year. Like I mentioned, we're trying to transition from being just purely an R&D and development company into a contract manufacturer and developing these things and getting these customers into multi-year long contracts, where we're delivering hundreds, thousands of parts depending on the application, on a regular basis. And that all comes down to backfilling our manufacturing facility with new orders that my team and I are working on at all times, developing more long-term partnerships. We have really deep ties with everyone in the specific kind of industries that we work in. So that's continuing to grow. Obviously, talent is really important. And really, we're looking for really kind of high-end engineers and scientists to bring on board to be able to kind of execute in the ways that we need to for these kind of advanced material science challenges. And obviously, keeping a resilient customer base is obviously important. Now looking at Cal Nano a bit by the numbers. So trailing 12 months, we're at about $4.5 million. We regularly serve 30, 40 plus customers a quarter, so we've served a lot over the course of a year. We have currently two patents around our two core technologies, which I'll talk about in just a second. And like I mentioned, we have 20 employees or so now, up from under 5 at the lowest point since I started the company. And so so I'll get into now the two core technologies. First one is called cryogenic milling, and the second one is called spark plasma sintering. So the first one here, cryogenic milling, it's a specialized grinding and mixing technique done at cryogenic temperatures. So if you can see kind of the picture here, inside of that is a shaft with arms, and that is all basically it's a big specialty mixer. But because it's all been retrofitted and done, it's done at cryogenic temperatures, you get some kind of unique properties, and that allows us to make nanomaterials, allowed us to make basically high performance alloys for all the applications that I mentioned. And the couple of the key things that it does, one is particle size reduction. So taking like larger powder particle materials, breaking them down into smaller ones. That's what kind of creates the nanomaterial concept. The other thing is making special alloys. So we can take different elements. So we can take, let's say, a titanium, an aluminum, and then a ceramic material, put that into the mill. It gets mixed up, and you get basically a new special alloy with unique material properties. Again, it could be higher strength. It could be special resistance to corrosion resistance, special thermal properties, electrical properties. So that's kind of one of the key things that we do there. And then on the strength side, one of the unique things that's really up high in the science level side of things is that you not only can break down the particle size, but you can actually change the microstructure. So like the internal part of the material to reduce the grain size and get what's called a nanocrystalline material. And that can come with a lot of benefits, but one of the main things is that it can enhance the strength. So we've taken a aluminum aerospace alloy, only cryo-milled it, no additives. And just by creating that nanocrystalline structure inside, we've been able to then process it, and then we've doubled the strength. So a lot of cool applications with this technology that we're working on. Second one here is called spark plasma sintering. So that's the other side of our core technologies. So this actually takes that powder or powders that our customers send us or we source and consolidates it into solid parts. So that's basically the idea, is using heat and pressure in order to consolidate it. And with this technology, there's a few different types of this type of sintering technology that are out there that are legacy technologies, and this is probably the most advanced of the type of sintering that's out there. And it's really versatile. So we can take, one time we can be doing an aluminum aerospace alloy, consolidating that. The next sample can be a high temperature boron carbide for like an armor application. And so it's been really great for R&D and trying to, you kind of go back and forth, and you can be really versatile there. And we're hoping to kind of use that same kind of concept and transition into kind of these commercial contracts that we're working on right now. And then other things, cost effective and short cycle times, just kind of go hand in hand. But because of the kind of uniqueness of how the temperature is applied, which is through electrical current, you can cycle times that in a normal sintering kind of furnace would take a day to days, we can do in a matter of a few hours. And really the thing that was missing for us was scale, that was kind of holding us back and keeping us in the R&D realm. But now with the new facility, I think we have that's where we're kind of how we're looking to expand and continue to grow the company. So so then here, just a slide on how, why would you invest in Cal Nano and sort of the key points there. So as I mentioned, really high technology, like really advanced technology that we have. And so we're working on like kind of the cutting edge of all these advanced materials. And that's really it's just a big push everywhere for people looking for what's the next best thing to work on in all these, kind of aerospace or nuclear or any of those type of things. So there's a big area, there's a big wave of things going there. And then specific to us, the spark plasma sintering, the adoption in North America, moving it from an R&D to a commercial kind of industrial process. There's been a growing wave since I started the company. Back in 2014, like it was people in the industry didn't even know that it existed. or only maybe a few niche people, but that has grown so much with hopefully the help from us doing that. But I think it's grown a lot, and there's continues to be more demand. Then zooming out in general for manufacturing, there's a big push to just bring manufacturing back here to the U.S. People are looking for domestic suppliers for various types of advanced, manufacturing capabilities, and so we're seeing a lot of things that from just for people wanting to just get out of China or because of tariffs or anything like that. So it's not only like the most specialized stuff, but even some of the stuff that was just being done in China or overseas, people want to bring back, and so we're definitely seeing some tailwinds coming from that. And then, as mentioned, we're transitioning from R&D into commercial. We see obviously going from just development programs. That $4.5 million in revenue really has primarily, if not all, been from just research development and growing that scope of work with our customers. And so we think there's a lot of potential going from the R&D and now moving into the commercial space. And then past profitability. So we've showed over the last 2 years that this business model can be profitable, really strong EBITDA, and we're looking to continue to kind of, right now we're at about back to about break even because we had a large customer in the green steel space that kind of went down a little bit in terms of kind of what they were doing with us on the R&D side, and so we're about here, but I think we've shown that it's a proven model and that it can kind of go back up, and then finally high barrier of entry. Because of the unique technology, the infrastructure that we've put in place, especially over the last 2 years, that I think there's a lot of know-how around what we do, and so it'd be it's difficult for a new player to kind of get into this market to kind of get through and kind of break into it. And then just diving a little more specific again on that. So we have the largest SPS systems here in North America that are available for kind of commercial services. We've positioned ourselves as a one-stop shop for our customers' needs. So we have a lot of secondary technologies and equipment around the 2 core technologies. So customers come to us with a material science challenge or project, and they don't have to go and source it from 3 or 4 different vendors to kind of get the whole scope of what they need for testing or analysis. We have all that in-house. And so that's been a really key driver, I think, in just the growth from where we started at, less than $500,000 in, revenue to now, 4.5, plus. So I think that's a big part of it. And, we continue to we want to take that same model and build it into the commercial space too, to add value to kind of our customers, and, what we can do for them. And then same thing, as it goes along with that is on the R&D side, we've worked with customers where they were trying to develop a new special alloy for, a given application, and they were going different routes for it, and it would take them 2 months to make one new alloy and get it tested, where we could take that same exact thing and we would do 3 to even 5 per week getting done with our process. So big, kind of big, like orders of magnitude, jumps in that of what we could offer our customers compared to what they could get elsewhere. Here we have the kind of a little more on the business model specifically. So the main driver for revenue is the kind of R&D and manufacturing services, and how that works is that customers will come to us. They will have some sort of need for our technology, get access to it for either R&D or looking to scale up to commercial, and then we'll work with them, getting some sort of scope of work together, quote that, and then be able to then execute on that work, all on the processing side. Many times they will provide the raw material too, so most of our stuff is just really on the processing side in terms of revenue. And then a little bit on the equipment sales, very small part of the business, but we do also sell some of the small scale equipment on the spark plasma sintering side. We kind of saw that as a strategic play to be able to kind of just people that don't want to use the services, but do want some equipment, especially on the lab scale, get in there, build a relationship. Then if they want to scale up to a larger projects in the future, we can be there to help support them. We also sell the tooling that actually goes into the systems to be able to run. So we've kind of built a nice little kind of side business based off of that too. So yeah, here we have kind of the three different trends that we see just kind of in the market. And the first one, like I mentioned, the kind of push for more advanced manufacturing here in the US. You know, between all the things that are happening with just the administration putting things in, orders in, and just everything going on there, we see that there's definitely a demand that is here for that. So we think we're kind of trying to position ourselves really well, position ourselves to be able to be a key part of that as there's that shift continues to kind of go this in that direction. Again, need for advanced materials. So we're working with companies who are always trying to push the boundaries of what's the next best type of material you can do, and you always want better material properties, you want better performance, and so our technologies lend really well to that. And like I mentioned, we were kind of stuck for years with just being able to do only small scale, but with the new build out for the manufacturing facility, those bigger companies are now taking notice of what we can do and the capacities that we have. So I think there's a big push going on there. Then finally transition from traditional sintering. So there's a lot of legacy technologies that are similar to the ones that we have. And so that's been where people have done for, you know, kind of the traditional way of sintering, but that they take long and they have economies of scale. So that's where they would, you know, beat us. But as we continue to build out and kind of grow our facility, and we get in some of the kind of more niche areas, we do that. We execute well. We get into these commercial contracts. Then, as we build out, we can then kind of break in and continue to kind of push into these other areas where the traditional sintering is just it's not really, doesn't get you as good performance, and we can break into those areas as well. This here, this is our kind of, we'll call it our flywheel. So kind of how the whole growth engine works for Cal Nano. It all starts with the R&D customers. It all starts with that. So that's where people come in. They have they want to start a development project. That's where it goes. We want to then convert those people into commercial customers, as many as we can, into, you know, kind of longer term commercial customers. That then lends more credibility in general to the technology, which then in turn kind of builds out kind of the market, you know, and gets more people interested in doing more R&D services, which then feeds back to getting more R&D customers. And then kind of the flywheel continues there. So here we have the kind of the growth strategy, like I was talking about before, the fact that we are looking for really, you know, industry clients that are trying to go into production is really what we've been targeting and what we're looking at for this. So kind of the pie chart there, you see the one customer we had over the last like 12 months, which was the green steel customer, that made up a significant chunk of our revenue, 1 point up to probably 65%. And so since they've taken kind of a back seat, we've really made that push to expand that red area there, which is the kind of industry and commercial, the diversification of our customer base. And right now we have 6, probably potentially more of customers that are in industry that are looking to go from R&D into, you know, kind of these commercial orders. We've announced a few of them. A couple, so the Orlicon and the Abtech are on the cryomilling side. So where we're basically processing powder for them for a couple different types of applications. One is for coating, one is for an additive into one of their products. And then also the military brakes one. So that was the one that we announced just this month. For right now, it was just a kind of letter of intent. We've been working with this customer for a long time, but is to make specialty military brakes out of their kind of special carbon composite material. And so that's a good application there. So here, just looking at some of the customers examples. So said we work with a lot of different customers. These are some of the different applications, advanced ceramics. So we're doing stuff in the nuclear area for special parts there. Refractory metals, that's basically just materials that are really good for extreme environments, high temperatures. And then thermoelectric. So that is an interesting technology that takes waste heat and converts it back into electricity. So that's a big one for for things like potentially into data centers. And so our technology is really well suited to make some of the raw material that gives better efficiency on that. Though here's just a little bit about the competitive landscape. So we're talking about we're really focused, again, we have R&D, but also the manufacturing services. And the only real competitors right now in the space are either the equipment manufacturers, who are obviously their goal is to sell equipment, not to do manufacturing, and then the labs who are just focused on the R&D side. This is a quick look at our, like I mentioned, our two facilities. We moved up from a 3,000 to a 20,000 foot facility. We still have both actually in operation. But that was a big jump for us for expanding our kind of capacity. This is a little bit about this is my team. So top row is the executive team. All these guys have been here for kind of since I've been. Chris was actually the original CEO who left and then came back to the company. And then the bottom, our directors have different kind of areas of specialty, some in MicroCap, some in advanced kind of material science, and then industrial manufacturing as well. So this is kind of, again, another kind of slide on trying to build a more resilient revenue base. So we had the big focus on the green steel customer, but now as we're looking here at Q2 that we've announced for this year, we've kind of diversified. So this is all made up of 30 different unique clients, a lot of which are trying to move from just the R&D into more manufacturing. So it's really been a big push for us with the kind of the green steel client going down. This just touches on our debt. Like I said, we became debt free at the end of last year, and so that was a big milestone for us. We're really excited that was able to happen. That was mostly through cash flows from kind of customer revenues that we had, and we look to kind of continue to strengthen that moving forward here into next year. Finally, this is just a quick overview of the cap table. So California Nanotechnologies, our ticker is CNO on the TSX-V, and then CANOF on the OTC. See the outstanding shares, about 20 million Canadian market cap at the moment. Insider ownership is about 40% or so, with the largest one being OmniLight Industries, which was the founder of the company also owned OmniLight and then founded Cal Nano. So that's why they ended up with a pretty high percentage there. So, all right. Thank you. Yep.
So the past visualization, your plan, California was not and yes, it's a potential backlog for sustainable revenue in 2026. Saying we got a base of $5 million, but there's more consistency to what might happen.
Yeah. So yeah, capacity. So asking about capacity right now. So that right now we're probably at only about 25, 30% capacity at the moment, based on like what you see for the revenues that we're talking about. So definitely significant amount of capacity still left and expanding on what we have. And then I think with those kind of commercial contracts, customers that we see, I think probably in that like in the $3 to $5, maybe $3 to $4 million of kind of consistent what we see kind of potentially moving into the future as a sustainable base. That's kind of where we're at. Plus the R&D work that continues to kind of grow. But that's probably where we are, and I think we'll continue to expand on that.
I noticed SpaceX is your customer, right? Can you talk more detail? What you do for SpaceX?
No. No. I mean, so they're a research and development customer right now. So we're not in manufacturing talks at the moment. But yeah, it's a research and development program. It's around the spark plasma sintering technology. They're not a large percentage of our revenue right now. They're not a large percentage. So they're still one of the kind of spread diverse of what we're doing. But we have talks with all these different companies, from your SpaceX to your Blue Origin to your Lockheed Martin, Raytheon. Like, we have all the connections within these companies, And I think, again, what was holding them back from moving from just purely R&D into, actually having bigger talks about what are the commercial applications out there was our scale. And even then, obviously, we're still relatively small, but a big leap from where we were when we had that conversation with them, 2 years ago. So these things take time. The cycle of time is 6, 9, plus months. But I think that's where the potential lies for Cal Nano.
Titanium versus aluminum, titanium grow like 3 to 10 times the cost. Triggers aluminum, you lose strength as it gets hotter, which is why people go to titanium. The magic nanocrystal stays staying and saying, okay, we've got 2 times strength. You still have that strength at higher temperatures, but what's the cost price of the custom, including the ceramics versus the raw titanium?
Sure. I would say that I haven't done the analysis of what it would cost. It does still have strength at that temperature, but I don't know what it would cost at scale. On the R&D side, it was more expensive, and we haven't done that project since we scaled up to the new manufacturing facility. It kind of it went away at the time. So I would have to do the analysis to see what the kind of at a larger scale what it would end up costing. So
It almost makes sense. Usually, with the particle size, you can show the particle size, but what do we use with the less than 10?
yes, yeah, we can. Yeah, we can control particle size, which will kind of affect what the end of properties are. And same thing, it's not only particle size, but it's actually, like I said, the nanocrystalline, like the grain structure. So it's controlling the grain size, which can kind of improve or change performance. All right. No other questions? All right. Thank you.